Hello everybody, let's do this. So for this lesson, we're going to talk about, here we have the graph of the derivative. So we know this is f prime of x. Here what we're going to do is we're going to find connections between f prime of x and f of x. So let's just take before we actually go into this example, let's look at one over here. Let me let's see. Let me zoom in a little bit. Okay. So let's imagine you have a graph of f of x, right? And this is f of x over here. What do you notice about f of x, right? For example, like when is f of x increasing, right? When is the graph increasing? So the graph is increasing from -2 to -1, and it's also increasing from 1 to 2, right? Because what do you notice about the tangent lines? They're positive. So let's take a look at this question over here. If f of x is increasing, where the tangent lines are positive from -2 to -1 and also from 1 to 2, what must be happening to the graph of f prime of x within this domain, right? If you know that if the graph is increasing from -2 to -1 and the graph is also increasing from 1 to 2, what must visually be happening for the graph of f prime of x? Okay, what I want you to do is pause the video and try and answer that question. Here, from -2 to -1 and from 1 to 2, the graph has to be above, the graph has to be above the x-axis. Because the idea is, you know that these tangent lines are positive, so if it's positive, then everything between -2 to -1 and from 1 to 2, it has to be somewhere here. What it is or what it looks like, I don't know, but I know it has to be above the x-axis. Okay? What do you notice from -1 to 1? What's happening from -1 to 1? The tangent lines, the graph is decreasing, the tangent lines are negative, so what has to be happening from -1 to 1? The graph has to be below the x-axis, somewhere over here. So an appropriate graph for f prime of x might be something like this, and that's the idea. Okay, so let's take a look at this question over here. Here it's saying, if we know that this is our graph of f prime of x, what do you know, which parts of f of x, what's happening within f of x, right? Here, where is f of x, what do you know, what has to be happening from here? Let's see. How can I answer this question? Notice that you saw how, let's try and do the connection like this. Like imagine if you know that f prime of x, if you know that from -2 to -1, f prime of x is positive. So what has to be happening from -2 to -1 for the graph of f of x? It has to be increasing, and that's what the question is saying here. It's saying determine for all intervals for which f is increasing. Well, it's just everything above the x-axis over here. You know that from -9 to -8, union -3 to 3, union 8 to 9, you know within this domain, f of x has to be increasing because you know that the tangent lines are positive within this domain. What about the next question here? It's saying when is f decreasing? It has to be from -8 to -3 and 3 to 8. Okay, so this would be -8 to -3 and union 3 to 8. All right. I hope that was okay. Let's look at the next part. Here, let's take a look at this question here. It's saying, and I'm sorry it's very faded, but it's saying here's the graph. Where would a local max be? This is f prime of x. where would a local max be at f of x? So let's just take a quick look at this scenario here. Here, if I were to ask you, where is a local max for f of x? Where do you know, where is the local max for f of x? It would be right over here. This is a max. And here, this is going to be a local, this is going to be the min. So what do you notice about the local max? Notice how the tangent lines go from positive to negative. And here, what is the slope of this what is the slope of this local max? You notice that this slope is 0. So let's take a look at this graph over here. Notice that, let's take a look at this graph here. Notice what is happening with the tangent lines from here to here. Notice how it goes from positive to negative. And that's what's happening here. It's going from positive to negative. So when we take a look at f prime of x and we want to find the local max of f of x, what we want to do is, where are the tangent lines? Where is it going from positive to negative? This is positive to negative. And where does it cross the x-axis? Notice that this is, so you have 3 choices. It could be here, here, or here. Notice this is going from negative to positive. So this doesn't work because we want to go positive to negative. This goes positive, 0, positive. So this one doesn't work. This one doesn't work. But look at this one. This is positive to negative. So you know that at x equals, at x equals 8, there has to be a local max at f of x. Because here we're looking at f prime of x. We're seeing when is the tangent lines going from positive to negative for f of x, and it's right here. Okay. What about a local min? Where would a local min be over here? We want to go from negative to positive. So where would a local min be at f of x? Here, this goes, let's take a look at this. This goes positive to negative, so we don't want this one. This one goes negative to positive, so this is good. This is positive to positive, and this is positive to negative, So it would be right here at x equals negative 4. Okay? Here is where the graph is going from negative to positive, so there must be a local min at f of x. Here, and the last idea, these 2 concepts of critical values, or you could say relative extremas. This is where basically the derivative, this is where f of x, this is where f prime of x equals 0. So critical values happen where f prime of x is 0. Where is f prime of x equal to 0? This is the graph of f prime of x. So where is f prime of x equal to 0? It'll be here, 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 and here. So at x equals negative 7, negative 1, 2, and what is that number? 7. Okay. I hope this helped. Try the delta math, and practicing the questions, you'll feel much better with this. Okay, I'll see you soon.